Yep, we're on page 3 of Parabolas. It's not considered as deadly as Ebola, but watch out. Okay, I'll have to kill that one too. The eccentricity. See, we always knew math people were eccentric. We live in eccentric city. The eccentricity of a parabola is equal to the number 1. We don't talk a lot about eccentricity, but when we do, if you can find the eccentricity, which has to do with C and A, when you find the eccentricity, if you know what the eccentricity is, you can tell exactly what conic you're looking at by what that is. So other than that, you just knowing that it equals 1, that's all you need to know for now. Okay, you don't need to know any more than that. In order to sketch a graph, it says determine the equation of the untranslated parabola. Oh, this is so cool. Okay, I just forgot what we were doing. We're going to sketch a graph. Are you ready?
Okay.
Okay, y minus 3 equals 1/2 times x plus 2 quantity squared. All right, this goes back to graph analysis a little bit and how we graph things. Do you remember our parent function for a parabola?
Yes.
Yes, it was y equal x squared, right? Mm-hmm. And so what we're going to do is end up translating this to fit this. Let me just do it. Here we go. First thing you want to pull out is you want to pull out your vertex. What's my vertex of this puppy?
It would
negative
be
2, 3.
Mm-hmm.
Okay. If you needed to add 3 to both sides to be able to see it, that's fine too. So far, so good?
Mm-hmm.
All right, so the first thing I'm going to do when I'm plotting this is I'm going to plot the vertex. So, negative 2, 1, 2, 3. All right, now tell me, is this going to open up or down?
Up.
It's going to open up.
And it's going to be really fat, right?
It's going to be fat. I don't know if I'd call it really fat, but it's definitely wider than a regular one because this number, its absolute value is between 0 and 1.
Okay.
So, yes, it will be wider. All right. Here's kind of what it's telling you here. Do you see down there where it says vertex?
Mm-hmm.
Okay, where it says vertex, you want to go ahead and write down this v equals negative 2, 3. Where it says untranslated parabola, that's where you want to write in y equals 1/2 x squared. Okay, now I want you to skip back to the top real quick. Okay, you see where it says determine the equation of the untranslated parabolas on number 2 there?
Mm-hmm.
Okay, look at that first one. The translations, when they're talking about a translated parabola, they're talking about where the vertex is. You know, how far up you moved it or how far left or right you moved it. That's what they're talking about for translations.
Mm-hmm.
So what we want to do is be able to look at an equation like this and pull out the untranslated part. The untranslated part here was the 1/2 x squared.
Okay.
Okay? It acts just like 1/2 x squared, except it just happens to have its vertex right here. So let's go ahead and look at those two that they have up there. It gives you y minus 3 equals, what is that, 2x plus 2 quantity squared, right? Do you see that one? Mm-hmm. And then it asks for the untranslated parabola. So what would my vertex on this one have been? It would have been negative 2, 3, right? Mm-hmm. What is left over when you're just looking at the untranslated one?
Y equals 2x squared.
2x squared. Perfect. So that's one of the things you want to be able to do, is pull out whatever the untranslated one is. Let's look at that second example there. It says y plus 2 equals negative 3 x minus 1 quantity squared. What's the vertex on that one? What is that?
It would
1,
be
negative 2.
Negative 2. Okay. And what is my untranslated one?
Y equals negative 3x squared.
Perfect. Okay? Now, here's what you can do. Let's go ahead and read through this. Part 3. Pretend, okay, the vertex is at 0, 0. Plot several points of the untranslated equation, always counting values from the vertex. That's just cool. So, what you can do is, once we've plotted this vertex here at negative 2, 3, we could think of this as being 0, 0. And then, if we put in, let's say, the number 2 here, okay, that comes out to be 4, right? 4 times 1/2 would be 2. So basically I could go over to up to. Ta-da! If I put in the number -2, I would go back to up to. So my parabola is going to look like that. Is that making sense? It's just like you're graphing a parabola at 0, 0, only you've moved the vertex. It makes your tables a lot easier. Are you seeing that?
Mm-hmm.
That's just a different way to plot. If you've plotted a lot, it's a lot quicker to do this than it is to just plug the whole thing in this big one. Do you not?
It's like the untranslated is you just pulled out the
A.
Yeah, you just pulled out the A.
Mm-hmm. Why does that work? Because
no, it doesn't seem like there's. I mean, I know the A is like a slope, but not.
Right.
And I see how that works, but if you see the A there, then why do you even pull out the A? What's the point?
Well, you want the A here because you have to. This affects whether it opens up or down or is skinny or wide.
Well, yeah, but you already have that in the equation. Why untranslate the equation?
Oh, because if I want to plug in something here, if I were just to make a table of x, y right here, right, if I plugged in 0, I'd get 0. If I plug in 2, I get 2. If I plug in -2, I get 2. That's a whole lot easier than making a table and plugging it back into this one.
Okay.
What the translating does is every time I plug in something here, it's going to have moved over, you know, it's going to go -2x and up 3.
Okay.
Do you see what I'm saying? So you're taking the translating out, so it just makes it quicker to plot.
Oh, okay.
That's why.
All right.
Okay?
Mm-hmm.
Let's pause that.